Hello everyone, nice to meet you. For the first time, I joined TPC, so I'm excited. I'd like to communicate or develop and learn Impl. So in this session, I talk about interface in Power 5. First of all, please introduce myself. My name is Kobaken. Please call me Kobaken or K-Fly. I'm Japanese. I came from Tokyo. I belong to Mobile Factory. My company paid for this trip. Thanks. Mobile Factory is developing web games, web service, and blockchain service. This game is called Station Memories. This is geolocation game like Pokemon Go. Pokemon Go collects Pokemon. This game collects stations. My company uses Perl 5. For example, Station Memories uses Perl 5. Next, I belong to Godan PM. This Perl community in Tokyo. I am the second leader of Godan PM, and the first leader is Kappa. Hi. When I held Godan PM last month, a newcomer from my company talked about the context of Perl. My colleague confused Perl 5 context, and Godan PM members taught him. And at 5 months ago, I organized YAPSI Tokyo. This is like the Perl conference in Japan. I think it is hard to organize conference, so I think TPC. I thank for TPC staffs and thank you. This is YAPSI Tokyo's hotel. They are speakers. They are drinkers. I think good conference and good community. That's all. Introduce myself. Conclusion: I love Paul, and thank you. Let's get into the main subject. I talk about interface in Power 5. First, example of interface in Power 5. DBI is my favorite Power module. Do you like DBI? Too? Yeah. And DBI is a great module. DBI provides to wrap some database stores, for example, MySQL, SQLite, Postgres, CSV files, etc. So we can handle data in unified interface without worrying about the specific circumstance of each data stores. It is very useful. And when we want to add new data stores, if we promise to keep interfaces, we can provide value to many people. So interface is very effective due to limitations. I would like to talk about this interface. Sorry. This is agenda. I talk 5 sections. First, I made function interface. So this module provides to implement Java-like interface in Power 5. Please take a look at demo. Sorry, just a moment. this package is interface. Could I see? Okay. And use function interface. Oh, sorry. And define function interface. Define hello and string the message and return of string and use type standard. This is interface, and implement interface. Use function interface Impl and hello interface, and so we can see error message in compile time. At compile time. So, and implement hello.
Relax.
Hello, TPC. Sorry. Not import type stuff. And so if edit complete implementation, and if change this message, and you can we can get error message at compile time. That's all. This is demo. Looks good, me? Looks good. Thank you. And this is features of function interface. One, typed interface definition, and check at compile time. So second section, what is goal and why do I make? So my goal is to make it easy to maintain large Perl applications. For large application, other language may be better. However, changing the language is difficult decision. So I want to be able to maintain large Perl application in Perl. So large Perl application have many objects. So interface define the interface of object. The interface facilitates conversations between objects. So more specifically, first advantage, it will be easier to fix implementation. We are expected to improve implementation. For example, to improve performance, security, readability. For more examples, to change MySQL 5.2 to MySQL 8, or to change Perl version. So another case, if I have written code in a hurry and made dirty code, so I need to refactoring. So if you keep interfaces, implementers do not have to worry too much about the object user. So, and you can change implementation. Now, second advantage, interfaces make stable dependencies. So stable means less change to the object. Stable means more change to the object. If an object depends on unstable dependence, object depends on unstable objects, we will have to check more. So in general, implementation is unstable. Then interfaces, it would be nice if we could depend on stable interfaces. So my goal is to make it easy to maintain large apps, and the interface is good for large apps. Also, next. So next, to understand more, let's talk about application example. I want to introduce the to-do application and then review to-do application. Case 1, inheritance case. So to-do repository inherit DBI. This class to-do repository to-do repository get to-do or insert to-do. So inherit DBI and implement select function, fetch to-dos, and to-do app user is using to-do repository, and I implement my to-do list. So let's review this design case. This shows current dependencies. To-do app depends on to-do repository. To-do repository depends on to-do tables and DBI. So if I change to the table, affected to the repository, and maybe affected to the app. No, so unstable dependencies. Next problem. Look at this evil method. And this is evil. So to the repository can use all features of DBI because inherit. I wish I could just take out to do. So too many features. And the next problem is to the app. Is it to test? First, when testing to the app, first to the repository. So Perl is good. Perl is good at mock. And is it a mock? Or do you use MySQL during testing? Test MySQL. So I want to write test code of only to the app class. So on logic. So as possible. So mock or MySQL process is no, I want. So messy this. So problems of inheritance case. One, unstable dependencies, and too many features, and messy to test. So Next, let's use law. So using law solves 3 problems in the case of inheritance. First, define interface using move rule, and implement to-do repository. And make DB handler injectable. And implement same select function. So to-do output depends on to-do repository interface, not to-do repository. And implement the same my to-do list. So let's review the lowercase design. And this shows current dependencies. To-do output depends on to-do repository interface, and to-do repository depends on to-do table DBI, and to-do repository interface. So in the case of inheritance, changes in to-do repository affected to-do output, but this case to-do output depends only on the interface. So changing the implementation of to-do repository is not likely to be affected, not affected. So more stable. So first problem is removed. And can we define the evil method? So no, I can't. So because we cannot any function of DBI because not inheritance. So necessary and sufficient features. So remove the second problem. So and the next implement to the repository for test. So this will reduce the mock code and the usage of my SQL in test. So be easier to test. And so remove the last problem. In this case, is there no problem at all? I think I have. Load can reuse the implementation. Load and this implementation can reuse. So load is too many features as interface. Next, I think the definition of the interface is poor. So, ambiguous input, ambiguous output. So ambiguous interface. In summary, there are 2 problems in load case. Last case, function interface. First, define the interface, select function, and the input and output declare. Unlike load, function interface does not reuse the implementation. We cannot reuse. So function interface solves load problems. Skip this slide. So looks good.
Go back 1 slide.
Okay. One more.
Forward.
Oh, sorry.
One forward, more, more, more. Is it forward or is it backward?
This is.
The last slide. Yes. Show the last slide.
The slide before the last one.
Yeah.
Pre-last slide.
Go to the final slide that you have shown and back up one.
Sorry.
Yes.
Yeah, we
that
want to
one.
see what you skipped.
Yeah, you skipped something.
Sorry. This slide, I want to see. To the implementation of to the repository is the same load, same as load. So to the repository and use function interface implementation. So use to the repository interface. Same load. And here, so we can specify interface in type Impl. Now this type is function interface types. Export this types. Sorry. Yeah, looks good. So I would like to talk about the contents of the strange mechanism from here. So do you want to use the mechanism as strange? It is now if it is myself. So I think talk about internal. So I think the function interface is on the shoulder of giant, and you can see that it is a simple creation. There are 4 requirements: function implementations and interface, and check if interface is implemented, and the interface type. First, function implementation. Function interface use function parameters. This module provides subroutine signatures. So we can specify parameters integer and die, integer dirty. We can get meta information of function argument with info function. So in this case, we can get inter A and inter B. We can get. Next, function return specify function return types. For example, this code return types int, and the return value is number. So I get error message at runtime. So and we can get meta information of function return with info types. We get int. So more details function returns. So we can specify multi return value types. For example, this called number and the string. This module enforces list context to simplify. So this is scar context. So we get error. So in large application, I think that is better not to use want array. So enforce list context. Now first requirements done. And next function interface. So this module uses keyword simple and the PPR. Do you know keyword simple and the PPR? Keyword simple created by Maoke. Function parameters use developers, and the PPR is Damian. Perl recognizer by Regix. So we define Perl hello return string interface, and we pass this string. So we get, and this is the pass result. So meta information is registered in the begin phase. So function name or package name registered begin phase. So we can get meta information of interface. So we can get meta information about interface. So second requirement is done. Next, interface is implemented. Check. So this is a use function interface impl. Internal. So we got function implementation informations, meta informations, and interface meta informations. So we can check if interface is implemented. Compare implementation meta information and the interface meta informations. Compare. And this runs at compile time. So third requirements is done. Last, we can get type constraints by function interface types. This module uses type tiny. Last requirements done. Okay, this is internal. In last section, I would like to talk about performance. So by checking if the interface is implemented, or by checking whether the return value is as expected type in the execution time but affected, no problem. So no problem because I'm Japanese. Because function interface impl runs at compile time, not run at runtime, and the function return has no check option. So internally, default case function return wraps function, and when use no check option does not wrap function. So during development or testing, check the return values, and in production, it would be nice to not check. Let's benchmark a case. This is benchmark cases. Case 1 default case, and the case 2 is function parameters and the function return and the function interface. Case 2 is not check case. case 3, no check, and without function interface, and case 4, just function parameters. So I want to. It is good if case 2 is early enough. So, これが I want to pass. I want to pass. So this is benchmark result. So case 1 is slower than other cases, and case 2, case 3, case 4 is the same. And it can be the same speed as using only function parameters. So there is no problem with performance. So, okay. Conclusion. In summary, function interface has the following features: typed interface definition, and they check at compile time. My goal is to make it easy to maintain large power applications. The first, I think the interface is effective for that. The first advantage is it will be easier to fix implementation. The second advantage is interface makes stable dependencies. Internal function parameters, function implementation uses function parameters and the function return. And the function interface uses keyword simple and the PPR. And the compare meta informations at compile time. The performance, the same speed as using only function parameters. So function interface input runs at compile time. Function return has no check option, so we need to use these options. That's all. Thank you. Any questions?
Hi, you're doing it during compile time. Did you notice, is it slowing down the compile time much? When you're working, do you notice the compile time being slower to run your tests versus not anymore?
Sorry.
Benchmark of compile? Seems
Probably you mean not noticeable.
yeah. As just noticeable or not?
Sorry. I don't use it.
What?
Loading a Perl interpreter takes longer.
Is it a noticeable change?
And
Like
just
1%
just
change?
you can just
Yeah.
benchmark your value on the cookie string on that will
Time.
compile time.
This is function return source code, and the function return log code difference. But no check case,
Yeah,
not log stuff.
that's runtime. That's
Uh,
the function.
Uh,
Runtime.
this is run at open.
Yeah.
Okay. Thank you.
And it's hard to blame the function interface if it's also loading Chinese things as well. So who's to blame?
As long as it's not taking an extra minute.
Oh,
It's all
okay.
Okay, that's.
So you probably mentioned it, but are you using interfaces like this in your production code base? This is something you use in your company? This is in production?
Not production ready. Sorry.
Version?
Version.
Is it released? Is it version 1?
Yes, yeah, you can use. But yesterday, I broke. Yesterday hackathon. So I broke it. Sorry. Any questions? Okay. Yeah. Thank you, everyone.